We're doing section 7.5, function composition and inverse functions. I'm going to encourage you to actually write that down on the top of your note sheets. 7.5, function composition and inverse function. It's at the top of your assignment also. All right, here we go. All right, composition of function. Let me explain what this is. Let me show you. It's more than one function that we're going to put together, and we're going to put it together not by adding, not by subtracting, not by dividing, but putting one function inside another.
Is that what these little open circles
Yes.
are?
You remember how I told you that multiply cannot be a bubble?
Yeah.
All right? Today is where you get to see where the bubbles are. They're actually going to be, instead of this bracket, it's actually going to be parentheses when you see them on your paper. They're actually going to be parentheses there. This means F with a G inside of it. I want to actually exaggerate this. Normally, you have an X in there, correct?
Yeah. Yes.
Instead, we're going to put the G.
So we have F of G.
The G of X inside of it, okay? So that means this F circle G, or F, this is, you say it F of G of X. This means I am putting the whole function G inside of F. You don't say it F circle G. You say F of G of X. Normally we had, when it was just, how do we say that one?
F of X.
F of X. And so if I'm going to take, instead of the X in there, if I'm going to put a G inside, it's F of G of X. Okay? G of X gets substituted into F of X. That's what this means. We're going to do some examples. All right, here's the time for the examples. Number 1. This says, find F of G of N. That means I'm going to put what inside of what? Am I putting G inside of F, F inside of G?
G inside of F.
G inside of F. That means that I'm going to take this n squared plus 3 and sticking it inside there. We did this when we did substitution. This, all you're doing is substituting. So the F of G of X becomes, instead of negative n plus 4, what goes inside the n?
N squared plus 3.
N squared plus 3.
And it's a negative.
And that negative is going to get distributed. So we're going to distribute that negative. We'll have negative n squared minus 3 plus 4. What does that become? This is why we couldn't make bubbles for our multiply, because bubble means something now. Okay? All right, number 3. Are we ready for number 3? What goes inside of what? G inside of X, G inside of F again. So I'm going to take this G, the negative X squared plus 3 minus 2X. Where's it going to go?
In the X above.
Inside the X above. So instead of X minus 5, it'll be...
X squared plus 3 minus 2x minus 5?
Yes.
It's a negative X squared.
Yes.
This one's...
All right, what do we get when we do that? There's nothing to distribute. Are there any like terms? So really, we don't even need these parentheses.
Yes, there is like terms.
We really don't need the parentheses.
Negative x squared minus 2x minus 2?
Negative x squared minus 2x minus 2. I agree. Okay, number 5. Now this is G of X.
So 2x squared plus 4 plus 2x squared plus 4.
Are we adding them?
No. 2 in parentheses.
I heard 2 in parentheses. Instead of 2x squared plus 4, what are we going to put inside the x?
2x plus 4?
2x squared plus 4, yes. We're going to put itself inside of itself. We're going to be G of X inside of itself. So we're going to go 2x squared plus 4.
And then we're on the square.
Now, do I distribute the 2 or do I square it first?
Square.
Be really careful when you square it. How do I square that?
You just distribute the
Do I distribute the squared? You don't distribute the squared. You would distribute the squared if I had x, y. If I was multiplying these two, I could distribute it.
Oh, so you can't. So you do the distribute first with the 2, not the squared?
You do...
4x to the third plus 8.
What?
We do 2x squared plus 4 times 2x squared plus 4. Or, Naraya, it's your square double square. So in here, if there's an add in there, we can't distribute the squared. We have to actually do the FOIL, or square double square. We have to actually multiply it out. If you need to go up on the side over here and write 2x squared plus 4 times 2x squared plus 4, and then multiply by the distributive property, do it, and then come back down. If you can do it in your head quick, then go ahead, okay?
Can you explain the square double square again?
Yes, I'll explain the square double square. All right, so we're going to have a 2.
It's easier than that.
We're going to, if you remember when you guys memorized your Formula Madness, you memorized that a plus b squared equals a squared plus 2ab plus b squared, correct?
Same thing here.
That's the same thing here. So I take the first one and square it. That's going to be 4x squared.
No, it's
4x to the 4th. So I take the first one squared. Then I take 2 times ab. So ab, that's a and b, and I double it. So 2x squared times 4 is
Plus
8x squared.
Yeah.
And then I double that, so that'll be 16.
X squared.
X
plus
squared.
16.
Yes.
So far we have
And then
2.
b squared, which is the last one squared, which is the 4 squared, which will be 16 plus 4. You with me so far?
I think so.
Okay?
Yep.
If we would have multiplied that out like up the top up there, we would have gotten that same 4x to the 4th plus 16x squared plus 16.
And now I'm going to multiply everything by 2.
So I'm a little confused about the 16x squared though. How did you do the math on that?
The 16x squared?
Yes.
Okay, that's the 2ab. And so we take 2 times this
Okay.
is 4x squared
Okay.
times b, which is 4 more.
Oh.
So that
okay.
makes the 16.
Yeah.
Okay.
You just don't mess with the squared. Yeah.
Correct, because there's nothing, yeah, okay.
No, I get it.
All right, so now we're going to distribute this 2 to everything. So we're going to have 8x to the 4th plus 32x squared plus 32 plus 4.
Are we going to need you to do a box method on this?
No, they're not asking us to factor it. They're just asking us to multiply it all out.
Oh,
Okay.
so we're done? Wait,
We're not done.
No.
We're not done. What do we still need to do?
The 32 and the 4, which
Yes.
is 36.
Yes.
I just combined the last 2 steps. I just did 8. I just made 34 in that last one. Or
Okay.
36.
Here we go.
I like these.
All right. You don't know factoring. No going backwards. Questions? The trickiest of them all was putting one of them inside of itself.
Yeah.
It's just a new way of thinking. Okay?
Shouldn't it-
We've been doing this a while ago when we just plugged one into the other. This is the first time we've ever had to plug it into itself. All right. What are inverse functions? We know that the inverse of multiply is divide. Inverse of add is
Subtract.
inverse of square is
Cube.
Square root.
square root. Inverse of cube is
Cube root.
cube root. So we've learned those inverses. Now we're going to learn how to find an inverse function, and we're going to learn how to graph an inverse function. Sometimes you want to do the opposite operation that a given function or equation gives you. To do the opposite or to undo the operation, we need the inverse function. I think you're going to want to write the steps down. Step 1, step 2, step 3, step 4 when we do some examples. So I'm just letting you know that you might want to write some notes on this one. And you might want to write some notes about this slide here. There are some properties about inverses. So if you had a function and you had its inverse, there are special properties. We're going to go some examples, but I'd like you to see these properties first. If you had a function and its inverse, their x and y values would be switched around. So if you got, for the original function, 1, 2, its inverse
2, 1.
will be 2, 1. Okay? For every single ordered pair that ever comes with the original function, the inverse will have the x's and y's will be flipped. The graph will be reflected over the the y equal x line, and I'm going to show you where that y equal x line is. Reflected means that everything that's on one side of that line will be reflected about the other line, like it's a mirror. the domain and the range will switch. So the domain for the original will be the range for the inverse. So they will have switched. Just like the x's and y's are switched, the domain and range are switched. All right, so here is a x and y graph. Here is a parabola. Can you see it? Mm-hmm. All right. So the inverse of that parabola would look like, that's the x equal y line, by the way, or the y equal x line. It goes 1, 1, 2, 2, 3, 3. It's all the way up there. And the other one is going to be flipped on its side.
Whoa.
All right.
So it's not perpendicular. I thought it was going to be perpendicular.
That's somewhat perpendicular. If you notice this y-intercept, let's say that's 0, comma,
What do you mean mirror image?
I'll show you in just a second.
All it is a
0,
straight line
comma,
from the
negative
side.
3. What was this ordered pair?
0. -3, 0.
Negative 3, comma, 0, right? So everything. And notice they intersect on that x equal y line. That's where they share a common point. All right, the definition of inverses. Let's talk about these. I think you should write these down too. Two functions are inverses if and only if. You've seen that if and only if in geometry.
Sentence.
If and only if. If you plug one inside the other, everything's going to cancel out and give you x. You just saw this notation once before. Or if we do it the other way around, you were asking about that a moment ago, if we can switch it around. If we plug one inside the other and then we switch it around, everything will cancel and give us just x. That's going to be a test. You're going to have a question today on your homework that says, are these two functions inverses? You're going to plug one inside the other and everything should cancel and give you x. But I'm not going to tell you how to do it. You're just going to have to know. So you might want to, at that point, put a little note next to yourself and says you need to do f. All right, remember that a function is when one x value only goes with one y value. But remember, we said it's not the other way around. F of x has to be a function to begin with, and that is a function. And the way we write the notation for inverse, I'm going to bring that up for a moment. F of x would be considered the original, and the inverse has a little negative 1 at the top. Be cautious, that doesn't mean you flip it upside down. This is the only time it doesn't in function notation. But if you have an f with a little negative 1, that will signify the inverse. F of x is the original function, and f with that little negative 1, like it's raised to an exponent, will be the notation we will be using for inverse. So let's do some problems together.
Yeah.
Hopefully, since you wrote that down, it'll be easier. And the question is, state if the given functions are inverses.
No.
So what we said we have to plug one inside the other, and everything should cancel out to be what? X. So I'm going to let you choose. Are we going to plug f into g or g into f?
I don't understand.
Let's do F and G.
Okay, so it doesn't really matter. You can pick. So I'm going to plug this whole thing right here. I am plugging this into that x right there, and hopefully everything will cancel. So here we go. I'm going to write the fifth root of, that will be x minus 2, and inside there I'm putting x minus 1 to the fifth plus 2. What we want is some things to cancel out. Does this fifth root cancel out to the fifth?
Yes.
Yes.
No. Why does it not? Anybody going to give me some ideas?
Oh, it's not.
Because it's got what in there? What's the extra?
Subtract.
Yeah,
It's
it
got
says
that
equals
plus
minus
2 in there. If this right here was like this, they definitely would cancel each other out. But that plus 2 makes it, so does anything cancel in this?
Well, yeah, we could take.
No, it's not an inverse because
It doesn't cancel out, so it's not an inverse. Let's do number 9. Do you want to put G instead of F? G instead of F or F instead of G? I don't care.
Yeah,
F
I
instead of G.
agree.
Okay,
Yeah.
so we're going to put this whole thing right here
Oh, there's going to be
inside there, correct?
Yep.
All right, here we go. I'm going to get rid of some stuff so we have lots of room. You said you want the top one inside the bottom one.
Yes.
Okay, so I like to write the negative 2 parentheses really big plus 1 cubed so I can fit it in there. So I'm filling in that blank, and I'm filling it in with negative 2 plus minus, thank you, the cube root of 4x all over 2.
Sorry.
Okay. What are we going to do first? Do you have any ideas?
I'm not done writing. What?
All right, I'll wait.
Okay, so we can't distribute the Q because it's a plus and not multiplication. But
Yeah, and we can't distribute this 2 in the front either because we got a cube
I'm
first.
saying with a fraction, can we do anything with a negative 2 in the 2?
Yes.
With
We
this
could
cancel.
give that 2 to both of these.
Oh, I was gonna say, would they just cancel out though, and then we would just have
No, because there's
minus
nothing
cube
in front of
root
the
for us?
cube root.
This will cancel in a sense, but we have to give this 2 to both. So I have to give this 2.
Oh, it just
to
becomes
both
negative
of
4, I see
these.
what you're saying.
So I can do it like this. I'll show you.
Yeah.
No.
Show me.
I can go negative 2, negative 2 over 2 minus cube root of 4x
Doesn't work.
over 2 plus 1 cubed. I can give that 2 to both of them. How does that help?
Well, that one over there becomes 1.
This becomes
So
what?
why
Be
not?
careful. This becomes what?
-1.
Negative 1. How does that help? Does it
Doesn't
cancel with
work.
something?
Well, does that make the other thing positive?
This is negative 1,
Oh,
and
it does
that's
cancel
plus
with
1. What
positive
happens
1.
with that?
They
So that those
cancel
goes
out.
They do cancel. So this
Yay.
cancels with that, correct?
Yes.
All right. So I'm left with negative 2, negative cube root of 4x over 2 cubed.
Oh goodness, I'm running out of room. All right, small.
I'm running out of room and I don't write small, so.
Now what?
Oh heaven. Do the negative 2 and the 2 cancel out now?
Do the negative 2.
Because that's just a multiplication and that's division. And we can't.
This negative 2 and 2, not yet because it's still cubed.
So do we have to distribute the cube first? And can we, because it's division? I know if it was
Yeah, we
multiplication,
can.
we could.
Yeah.
But-
So yeah,
Can
make-
something cancel? Something
Oh,
cancels
yeah,
right now.
The cube root and the
The cube root and the
Yeah,
cube,
the cube
right?
root,
But what if I do it with the 2 on the bottom?
You cube it.
Okay, which becomes what?
8.
Okay. So I've got a negative 2 on top, and this cube and cube root go away, right? Because I can distribute that cube to the top and bottom, right? All right, so I'm going to have, what am I going to have left on top?
4x
Careful, almost.
4x.
Negative 4x.
and then 8.
All right, now what happens?
They get multiplied. And it becomes a 4 and an 8x.
Okay, I have 8x over,
8.
and what happens now?
You get
The
an
2
x.
8s can cancel.
Becomes x. So, what does this conclude? Is this an inverse, yes or no? Yes, because we just got yet. All right. When you have a square, what will cancel a square?
Square.
Square root.
Yes, what will
Yeah.
cancel a fifth?
Cube root.
Oh,
Fifth
fifth
root.
root.
Fifth root, what will cancel a third?
Cube root.
Cube root, okay?
But up here we had a 5th and a 5th root and 7 and they didn't cancel.
That's correct, because we had that extra add in there. Now, the nice thing about this one is we had something that could cancel out that one.
Yeah.
That helped us, then we could take the cube and the cube root. All right, let's do number 11. We're going to find the inverse. You're going to need to use your sticky note or another sticky note to write some procedures. I'm going to tell you these procedures. I'm going to do them and to go slowly until you can write the steps. The first thing we're going to do is we're going to trade out that g of x for a y. So I think you should write that down. Number 1, you're going to trade out the function notation for a y. Number 2, we're going to switch the x and the y. I'm going to let you catch up even with your notes and now doing it, okay? So write the y equals 5x minus 10 over, all we did is we just made that be a y. Now I'm going to have you now do it, and I'll do note step number 2 in a moment.
Wait, so you want us to do step number 2?
Not yet,
No.
just do step number 1. I haven't done step number 2 yet. Step number 2, all we're going to do is in the place of that y, I'm going to write x. In the place of the y, should be the x, I'm going to put y. You with me so far?
See.
Okay. Step number 3, and the last step that you'll write down, is solve for y. Step number 3, solve for y. All right, so how do I solve this equation here for y? I have to move the 6 out of there. How do I move the 6 off there?
You subtract it.
Multiply by 6. So it'll be 6x equals 5y minus 10.
And then we're going to add the 10 over there.
Add the 10 to the other side. So I'll have 6x plus 10 equals 5y. I'm solving for y. I want to get this 5 off of the y.
Divide everything by 5.
Divide everything by 5.
No, we're done.
Yes.
But you can't have a fraction as an x.
You can. We're not doing standard notation, so you're fine. If you want to write this as a last step, step 4 if you'd like, write it in inverse function notation.
How does that work?
I'll explain what that is if you want to write that down for step 4. Remember we said the original was f of x. What's the, or in this case, g of x. What's the inverse notation? What did we say the inverse notation
Y
was?
of it.
We said 1 will be the function notation, and what will be the inverse notation? You wrote it on your little notes over there. G. So g of x is this one, and our answer will be written like this. G, or we say inverse of g, is going to be 6x plus 10 all over 5. This is the inverse function of that one. If you took this one and plugged it into that one, what would happen?
It cancels out.
Everything that cancel out to be x. Let's do number 12. What's the first step?
Make the G away.
Take the g away and put a what in its place?
Y?
Very good. Put a y in its place. Now what do? Switch the x and the y. So x will be out here. Now we need to solve for y. So what are we going to move first? The 1. Add the 1. We'll have x plus 1 equals the 5th root of y. How do I get rid of...
By 5.
Not multiply by 5.
Divide.
To the 5th power.
Right.
Yes. To the 5th power. The whole thing to the 5th power. So we'll have y equals... If at this point you just want to start, you're all done with the y equals, we could just go to the function notation now, the inverse notation, and say g, is it g? Yes. G inverse is going to be what?
X plus 1 all to the 5th. Or open parentheses, x plus 1.
Yes. Here we go. So, if you look at this one, it is the inverse of that one. And we could prove it. If you wanted to check your answer to make sure you were right, you could plug that one back inside there, and everything should cancel to be x. Okay? Here we go. Are we ready? We're going to graph some now. Let's just graph the original. 2n plus 5. This is, what is this one going to look like? Is this going to be a parabola? Is this going to be a cube root, a line? What is this going to be? It's going to be a line. What's the y-intercept of this line? 5. It's going to be 5. So we're going to go 5. And the slope is 2. Can I go up 2 and over 1?
No.
So I have to go
Down 2
down 2 and back 1. I'm going to just keep doing that a couple times. All right. Then I'm going to get my line out here. I need to have an arrow on it. I'm going to go like that and then like that. All right. That's the original. Tells you to find the inverse, then graph it in its inverse.
So
you don't
we're
have
not
to do it in that
supposed to graph
order.
The original?
Graph, it says then graph the function and its inverse. Okay, so here's the original. I'm going to kind of do this a little backwards. It doesn't really matter.
And the inverse is
The
negative
inverse,
5.
we just flip all these around.
Yeah.
So this is 0, 5.
And then negative 2.
And so we're gonna-
negative
our-
5 comma 0.
No, so it'd be 5, 0.
We're going to come down here on the x-axis. It's on 5 on the y-axis. We're going to do 5 on the x-axis. And this, what's this? This is negative 1, 3.
Yes.
So what will be the inverse of this one?
3, negative 3, 1.
3, comma, negative 1, right there. All right. So this ordered pair, this one over here, is negative 2, 1. So it's going to be 1, negative 2. And this should be in a straight line, by the way.
Now I have my slope though, so can I just...
You could just keep going down 2 and over 1, down 1 and over 2, down 1 and over 2.
And eventually they intersect, and that's what we're looking for? Is that it?
We're not really looking for where they intersect, although they will intersect on this line that goes like
They intersect at -5, -5.
Yeah.
They intersect on this line here.
But we're not looking for the intersection.
We're not looking for the
You got a
intersection.
problem with the intercept, y'all?
But we're not looking for it. So
We're not looking for it, but it does
I
intersect.
was.
If it does intersect, it would intersect on that. This is the x = y line right here.
Then we're done. This is like this is delicious.
All right, here we go.
I like this.
This is such a gay term.
What?
Delicious.
Delicious.
No, it is not. No,
it's
it's
It
not.
not.
is. It's a terrible.
Our two graphs. I made one looking a little better. The line's a little thinner there. But we have our original one. I have it in black here. The inverse is in blue. But it actually told us to find the inverse. What is the procedure that we go through to find the inverse?
What we just did, right?
Yeah,
Yes.
that whole
So we
thing.
make that f of n become
a y.
a y.
Y equals 2x plus 5.
And we could say x, but I'm going to leave it n. 2n plus 5. Then we flip the what?
The y in the end.
The y and the n. And we're going to have n equals 2y plus 5. I'm going to now solve for y. So we're going to move the
5.
5 over. And so I'll have n minus 5 equals 2y. Divide by 2. We can now do our function notation. Instead of f of n, we're going to have the inverse. And how do I write the inverse?
Y.
F to the negative or
one.
inverse n. Don't forget you're using n equals n minus 5 all over 2. There is your inverse. I want you to notice that, see this x = y line? Do you kind of see how the distance between, if I, just so you can observe, if you connected these dots, these distances are the same.
That's cool.
All right? So this is reflected, meaning it's the same distance from this line.
Man, you're turning
Okay.
out to be an aristocrat. Someone has more time to figure that out. Dang.
You're an aristocrat.
I'm just picturing
Believe
a
it or
fan.
I can't be an aristocrat. I don't
Number
have time.
16, here we go. Number 16. We're going to graph. You know how to graph y equals x cubed?
0, 0.
Start at 0, 0. Is that the one that goes up
Goes
tall or up to the side?
up tall. No, to the side.
Which is it? Up to the side or up tall?
It goes to the side.
This goes to some.
It goes to the side. Okay, so we have 1, 1. And does it go backwards also?
Yep.
Okay. What is the rule for this one? I go out 1, up 1.
1 times 1 equals 1. 2 times 2
We
equals
can't.
4.
We can't. Do we not have enough room?
No.
We don't. So we're going to have to just fake it. So we're going to go.
Lovely.
Yay!
Okay, there we go.
We live kind of sort of close enough.
What's the inverse going to look like?
The same thing going up?
No, it'll be the side.
What, now, this is a cube root. What's the inverse of cube root?
Negative.
Cubes? So the same
So-
thing going up?
Yeah, it'll be to the side, actually, I thought.
It'll
We'll make an X.
No, it'd be going up. Right? Up.
be going up. It'll be going like this.
Yeah. Oh, that's cool.
My mom.
They're inverses of each other, right? Cubes and cube roots?
Now I want to do this in a different color, but
I know.
I'm gonna mess it up and I'll be like, no.
I have yellow on the otherwise, unless you want a bunch of markers I have, but
Wow, those are so cool.
green. All right, so how do we find the inverse of this one?
That looks really weird, but really cool.
We
So
turn
instead-
it into a y, the g of x into a y.
Okay.
And then we bring that over and we get cubed x. And now we got to switch the x and the
Switch
y.
the x and y, so we'll have x equals the cube root of y, and how do I,
To cube everything.
we cube both sides, and we'll have x cubed equals the inverse, g inverse this time, of x. There we go. So we just verified the graph, right? We said that if you didn't know how to graph this one, you could have found the inverse and verified, hey, it's a cube. I know how to graph a cube. It goes up. Okay.
1 second, I'm jotting all that down.
Oh, man.
Wow, that looks really unique. Mom, she was taking notes on that. Sorry.
No problem.
I don't take notes.
All right, we learned We learned how to do composition of functions. That's where we take one function and we put it inside of another, okay? We use that composition of function to do inverse functions and to verify that two functions are inverses. We found them by switching the x and the y and then solving for y. If an inverses are functions of each other, then, and we learned how to graph them.